Okay, I'm live. Okay, here we go. Today, review. 9, 5, 19. Okay, let's go through it. So number one, find the domain. So number one, first of all, we can't have square roots, right, of negative numbers. So I'm going to just simply take my 5x minus 25 and make sure it's greater than or equal to 0. That's, to me, the easiest way to start on this problem. It's just we know this, what's inside, can't be negative. So if I start right up with 5x minus 25 is greater than 0, then solve for x, right? And then the domain is going to just happen. So plus 25 plus 25, 5x is greater than or equal to 25. Divide by 5, and x has to be greater than or equal to 5. That is the domain. So if I think about it, and if I plug in anything less than 5, I should be in trouble. So if I plug in 4, I'd get 20. Minus 25 is a negative number, right? So everything bigger, greater than or equal to 5 is my domain. Number 2.
Is that how we do it?
That's one way to do it. The other way is to look at it intuitively and say, okay, well, I can plug in 5, right? I can plug in 6, but I can't plug in 4. That's doing it intuitively, okay?
Why?
No, go, Sydney, please ask.
Why can't you plug in 4?
Great.
Is it equal to or less than 25?
Right. So let's just check it out. Great question. Square root, right, of 5 times 4 minus 25. Now, I'm going to get 20 minus 25, which is a negative.
And you can't have negatives?
No, I can't take square roots of negative numbers, right?
Can we use calculator?
Sure. Okay, number 2. Can't divide by 0, right? So for sure, x cannot equal negative 3, right? But that's not the domain. That's just the restriction. What can x be?
All real numbers?
Yeah, all real numbers.
This is the range?
Except, no, this is the domain. And so it can be everything.
Oh, we're on number 2?
Yeah. It can be everything except it can't be negative 3. So you have to say both, because what is the domain? What can it be? Everything except negative 3, okay? Number 3, hopefully super easy. We know it's a straight line, right? It looks something like this.
Wait.
Yeah.
Oh, never mind.
So we know number 3 is a straight line. So it's not a trick question. It's just all real numbers. You guys agree? You can plug in anything, right? So the domain is just simply x is equal to all real numbers, okay? 4. This is a half circle. We know that if we plug in 4, we're okay, right? If we plug in 5, we're not. Think about it. If we plug in 5, 5 won't work. 5 doesn't work because 16 minus 25, right? We can plug in negative 4, right? But we can't plug in negative 5 because if we plug in negative 5, we'd get a 25. We'd square negative. So it's a half circle, and it really looks something like this, from negative 4 to 4. So my domain is negative 4 is less than or equal to x, which is less than or equal to 4, or in interval notation, right, Sydney? Or bracket negative 4 comma 4. I like interval notation better also, okay? How am I doing, okay? Okay, 5. I can't divide by 0, and it can't be negative. So I'm going to say 2x plus 1 is greater than 0. Can't be equal to 0, because when we divide by 0, and it's got to be positive. So I just start out with the statement 2x plus 1 has to be greater than 0, and I'll solve. Minus 1, divide by 2, x has to be greater than negative 1/2, okay? So if I plug in any value bigger than negative 1/2, I'll be okay.
Wait, number 4.
Yes.
So it has to be greater than negative 4, but it has to be greater than or equal to 4. So
Yes.
it can't be anything in between, is what it's saying.
Just the opposite. It's everything in between,
Everything in between.
but nothing on the outsides.
Okay.
Yeah. And you can see the graph, Sydney. The graph does exist in between negative 4 and
And
4.
you can graph that as well. And look at it.
Yes, you can. Yeah. Yeah. The calculator won't show it touching, but it does.
Okay.
Okay. All right. I wonder if Desmos might show it touching.
Probably does.
Probably does.
Why doesn't it show it touching?
Why doesn't it show it touching?
Yeah.
Okay, so great question. We know what a function is, right? So if it's straight up and down a vertical line, it's not a function. Right? For example, if I had this line right here, okay, is not a function, right? So this, technically a line has no thickness. Are you with me on that? No thickness at all, right? A line is that thin, okay, with me? But on the calculator, it has thickness, just like this line here has thickness, right? Because I just drew it with my marker. So in the calculator, we've got these things called pixels, and as the pixels get closer and closer, let me show you, okay? Because you're asking a great question, okay? Clear that. Y equals clear square root of 16, subtract x squared. Okay, let me try and check my window. I'm going to go -5 to 5 and 0 to 5. Let me graph it, okay? Now, so right about here, the calculator would have to draw it vertically straight down, wouldn't it? So the calculator would say, wait a minute, I can't do that because it's not a function. And because it has some thickness here, it would have to draw a vertical line. It won't. It just won't do that because it wouldn't be a function there. But a line is not that thick. A line is that thick, right? So it does touch. Does that help explain why?
Yeah.
Okay. Now, 6. What I would do on 6 is I would factor. This is what I would do. I would rewrite it as a 2x plus 6 over parentheses x plus 2x minus 2. Okay? Can't divide by 0. So x cannot equal what? Cannot equal,
-2.
yeah, and, right? But that's not the domain. That's the restriction. What's the domain? All real numbers, right?
Wait, I did it a different way.
What'd you say?
So I did x squared minus 4 is greater than 0.
Okay,
Then I factored that,
okay,
and then I got -2 and 2.
yes.
So you can do that?
As long as you say it cannot equal -2 and 2, okay?
Yeah, so wait, what I did is -2. Oh, wait, but it can be numbers above that.
Yes, it can. Yeah. Okay. Okay. Now 7, 8, and 9. I'm going to do on a separate sheet of paper. Does that make sense? Because I'm never going to have room for number 9. Okay. So on 9, I'm going to go. Okay. So first of all, 7. I've got x squared plus 2x minus 3, and that's f of x. So first of all, 7 is f of a, and everybody should be able to get this on the quiz, right? F of a. Okay, want me to slow down for a second?
Yes.
Okay, gotcha. Give me thumbs up when you're ready.
Wait, what's the little thing before the F?
Here?
Number 7.
Oh, it's number 7.
Oh,
Yeah. Okay, so it's just going to be a squared plus 2a minus 3. You're just going to plug in a, right? That's it. Okay, 8. We're going to go f of a plus h. Okay, so it's going to be a plus h squared plus 2a plus h minus 3. Now that answer is fine, and I would take that answer on the quiz. Just boom, put it down, done, you get it right. However, just because I know it's common, I'm going to take it a little further, okay? You all right with that? Okay, so take it a little further. If I FOIL this and have an a plus h, right? If I FOIL it, again, go ahead and give me that answer. But we're going to need to simplify it for the next one, okay? So then I have an a squared plus a 2ah plus h squared plus 2a plus 2h minus 3. And I skipped a step on the FOIL, okay? I skipped a step on the FOIL, okay? But we've done that a few times, right? We should be getting okay on how to FOIL that, okay? Now, that helps me for number 9, because on number 9 I want f of a plus h minus f of a all over h. Want me to relax for a second?
Yeah.
Let you catch up?
No.
Okay. So, I'll take the second answer, I'll subtract the first answer, and divide the whole thing by h, right? So, Glenn, am I going too fast? I'm okay?
No.
Right, so I'm going to go a squared plus 2ah plus h squared plus 2a plus 2h minus 3. And I like brackets. I really do like brackets. You don't have to put brackets. I like brackets. Minus my f of a, which is going to be my a squared plus 2a minus 3, bracket, all divided by h, okay? Now, I've got some simplification to do. Remember that all of the f of a's should cancel. They should.
But don't you have to include the negative?
Yeah, let's do that. Let's do that so we don't make a mistake, okay? So negative a squared minus 2a plus 3. Nice job, Landon. That way we don't make a mistake with our double negatives, right? Okay, and then that will cancel with that. And that will cancel with that, and that will cancel with that, okay? So everything of the a's should always cancel. If it doesn't, you've made a mistake, okay? So let's see what we got. I've got a 2ah plus an h squared plus 2h all over h, right? Common factor out the h. 2a plus h plus 2 over h. Cancel the a's. 2a plus h plus 2. And that is the answer. But if it was calculus and h becomes 0, you've got the slope, 2a plus 2, for the curve. Pretty cool, huh? Okay.
Wait, sorry, can you hold up a second?
Yep, of course I will. Okay, 10, I'm going to need a piece of graph paper. So while you're working on that, Landon, I'm going to get my XY axis going on my graph paper, okay? And give me thumbs up when you get it, okay? Okay. There we go. All right. So, all right, let's see what we got. All right, first thing I like to do is put in my border lines, right? That's the easiest way for me. So I put them at -6. 1, 2, 3, 4, 5, 6. Borderline. Do my border lines right here. Do my border lines. -3, 2, and 5. Okay? Got my border lines. Okay? Can you see that? Yeah. Yeah, but they're supposed to be invisible anyway, right? First equation is y equals 3, -3, horizontal line at -3, but I'm just going to put it right into the first region, right? Open circle here, open circle there. Second equation, 6 minus x squared. It's a parabola, but it's upside down. It's a parabola, but it's upside down. It starts up at 6. 1, 2, 3, 4, 5, 6. I do the t-table. Remember how I like to do with the t-table in my head? 1, 1, 2, 4, 3, 9. Sydney, do you know what I'm doing when I do the 1, 1, 2, 4?
Yeah, you're plugging in 1, 2, 3.
Smart girl. There you go. But it's upside down, right? So 1, 1, 2, 1, 2, 3, 4, and I'm going to stop there.
Have you
One.
got the negative?
Yep.
Coordinates upside down?
Yep.
Yeah.
And they're all open circles?
On this one, but I'm going to fill this one. Oh, no, I'm not
They're
going
all
to.
open circles.
I forgot to write that in. That's okay. Well, that's going to mess up my domain, so I may have to fix something, okay? Let's fix it right now, just so, because it's really going to make the domain bad. So let's make them all closed circles, okay? Obviously, when I was making this up, I should have gone back. So let's put an equal there. Okay, and then y equals x. Yeah, let's put an equal there. Just so, because it really will mess up my domain if I don't do
Wait,
this.
so why aren't you putting the equal on the -3 or the -2?
I already have it on a -3,
Oh,
and I already have it on the 2. Good question though, right? Because you got to count it once, not twice, right? Okay, and then y equals x, so 1 over 1x plus 0, so start at 0, up 1 over 1, it goes like that, right? You guys with me? But it's only right there. Okay? There it is. Domain. Don't mess with my domain, right? And I'm going to use interval notation because I like it better. -6, comma, 5. And again, your domain is always going to be there anyway. Does that make sense why your domain's just there? Because that's the beginning of the x's and that's the end of the x's, right?
Isn't your first, isn't it an open circle?
Oh, I put, yes, but I,
Oh, okay, you fixed it, 'cause- okay.
yeah, thanks, Cindy, yeah. It would be, except for I fixed it. See the domain, if I didn't put those in there, the domain would be from here to here, and then from here to here, and from here to here, and that'd be annoying, right?
Yes.
Right? Range is going to be at a low point of -3 up to 6. How's that? Thumbs up? Okay, guys, ready to turn the page, or am I going too fast?
One second.
Okay.
Yes.
Okay, you good?
Yeah, go for it.
Okay. All right, now let's do the opposite. Okay, on 12, I see 3 equations. Equation 1, equation 2, and equation 3, right? Equation 1, let's see, it is
Is it just X?
x plus 4?
x plus 4. Where'd the plus 4 come from? Y
It
equals,
starts at, or it's intermediate.
but it got erased, right? It would have gone through 4, but got erased. Equation 2, y equals,
2
-1/2 x.
plus 3.
Good, plus 3, right? Equation 3, 2x, right? Now let's see how smart we are, okay? Listen to what I say. Listen to what I'm going to say, okay? Everybody listen and look. Okay, what's the height?
1.
-1.
Yeah.
Then it'd be -3. Then it would be at -5. Then it'd be at -7. Then it would be at -9. Can we do that again?
I don't get it. What?
Okay. Okay, you ready? So it's going down, right? It's going down, it's going down, going down, going down. So if I move over 1x, it's going to go down 2, isn't it? Because it goes down 2 over 1, down 2 over 1.
Bringing it down, oh, but you still have the graph of it.
Right, right. So I could get another piece of graph paper. I could make it longer, but let's see why it's going to be 9. It has a height of -1. I'm going to go down 2 more.
It's 2, 3,
Down 2 more.
6, or 5,
5. Go down 2 more.
7,
Down 2 more.
9.
So it would cross at 9. Now do you see how I did it? You could always just get a piece of graph paper and do it, but it should be 9, okay? So now, this one exists between -4 and 2, right? This one exists between -2 and 4. This one exists between 4 and 6, okay? So, here's how I want to write it, because it's a function. I'm going to go f of x equals, right? I'm going to go x plus 4 if. And if you want to use the interval notation, that's fine. You like interval notation? I'm going to do it the other way just because I do. Less than equal to x less than 2, okay? We're going to go -1/2 x plus 3.
Wouldn't it be -2 on the first one?
Makaiwa. Yes, 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 thank you. If we're between -2 2 and 4 and 2x minus 9 if we're between 4 and 6. There's my answer.
If you were the other way,
I would just use these.
use those. Okay.
Yep. And Sydney, that's fine. It's not, on a piecewise graph, it's not common to use interval notation. It's not wrong. But in piecewise, we usually do the set notation, okay? But I would take it because it shows understanding, okay? All right, 13. You guys ready for 13? So not too hard because it's a graph, right? So when is the weight increasing? Well, looks like it's going up here, right? All the way to there. It's increasing to there. And it's also increasing to there. You guys agree?
0 to like 29.
Yeah, I'd go 0 to 29. Sounds about right. So from 0 to 29, and from maybe 31. What do you guess? Want to say 31? And from maybe 31 to maybe 65. There's my guess. You okay with that? Okay.
Wait, how come one's a graph? I mean, zero's a
Well, that's a great question.
If you start there,
You know what? The moment you're born, you know what?
So on that one.
So in that.
Maybe I'll change it. I mean, the moment you're born, are you growing?
yes.
Yeah.
So do you want to put a bracket at 0 moments? It's up to you. Bracket or parentheses? I guess that's a question, right?
Would you accept either?
Of course, in this question. Yeah, absolutely. Because you could argue, oh man, I was growing as I was coming out of the womb, right? Okay. When is it decreasing? Probably between 29 and 31, right? What was the maximum weight? And what year? Probably about 200 and maybe it's 65, right? 200 pounds and at maybe 65 years old. And that changed from 10 to 20. So what is the weight at 10? And what's the weight at 20?
400.
150 maybe. So my net weight change would be 100 pounds. Yeah. Okay, what do you think?
No homework.
No homework. You can just cross it off. There you go. How's that? Okay. You're welcome. Okay. So I'll be here tomorrow at Flex if you have any questions. Okay.
What did you say?
I'll be here at Flex tomorrow if you have any questions. I'll be here at Flex. Okay?
So, you know how I had a Spanish lesson?
And stop the recording.